Good morning, Build Stuff. How are you? Any hangovers in the room? Just little ones, maybe? So, there we go. My name is Dylan Beattie. I am a systems architect. I'm a software developer. I am a huge nerd. I am going to be talking to you today about webmasters, full stack developers, and other legends. But before we start, I have some very disturbing information. I have it on good authority that some people in this room have been writing ASP.NET Webforms. Could they please raise their hands? Come on, Pete, I know you've done this. Now, under new legislation, we have determined that ASP.NET Webforms is actually a crime against humanity. And you are all going to be sentenced to think about what you did. However, here in the Baltic states, we are very progressive and very liberal. So we have a choice of two different kinds of sentencing. In the first scenario, you go to jail. We're going to lock you in a room with bars on the windows, and you are not allowed outside. You can go to hospital, you can vote, you can go to court, but that's it. No visitors, no traveling. Yes?
Can I still write my VB script?
You can, because this is a special kind of jail. This jail has broadband and a mailbox. You can use Netflix, you can use Skype, you can send email, you can work, you can manage your AWS cloud infrastructure. If you can find someone who doesn't mind the fact that you're in jail, you can work from jail and earn money and order things from Just Eat and sit and eat bagels and curry and do your job and basically do whatever else it is that you do. You're just not allowed to go outside ever again. The other option is that you're free. You can travel, you can see the world, you can go to Machu Picchu and climb Mount Everest and go to the North Pole, but you're not allowed to use the internet anymore. At all. No email, no online check-in. So you're going to need to find an airline who will let you pay cash and give you a paper ticket. No smartphone, no Skype, no broadband, no Netflix, none of these things. So we're going to let you choose. Now, your sentence is 2 days. Hands up, who would rather be in jail with broadband for 2 days or traveling the world with no internet at all for 2 days? Jail? What about if it was a week? A month? A year? At what point do we actually determine that the internet is now so fundamental to the way we live, the way we communicate, the way we socialize, the way we work, that we would actually give up liberty and freedom of movement in order to continue to enjoy it? Because the internet and the World Wide Web has transformed all of our lives. There are probably people right here today in this room whose parents met due to an algorithm on an online dating website. I mean, they'll tell you that they met at a Pearl Jam concert, but the internet is absolutely transforming our lives. And what we're going to do today is talk a little bit about the history of the web and how the web has been developed by the people who've worked on it over the 25 years or so since the web was first incarnated. The first experiments with packet networking and what we came to know as Ethernet were in the 1960s. A guy called Bob Metcalfe was working at Xerox. In 1968, they did a thing at Xerox called the mother of all demos. This was astonishing. In one demo, they showed hypermedia, they showed video conferencing, they showed networking, they showed mice, they showed a first windowing system. Hands up who's got a Xerox smartphone? Yeah, nobody. Xerox should have been Apple, and they should have been Apple 20 years earlier, but they just never quite clicked with that thing of turning their good ideas and their innovation into products. They make very successful photocopiers, I hear. In the 1970s, they developed the idea of packet networking and a network which could cope with one of the nodes in that network becoming unavailable. This was quite a lot of concern to the United States Department of Defense because they, for obvious reasons, needed a network where if one of the sites was to suddenly disappear in a sort of big mushroom cloud thing, the others could keep communicating. You could argue the toss about when the internet was actually invented. I'm going to say it was 1982, because two things happened in 1982. One is they adopted TCP/IP as a way that networks could connect to other networks. IP addresses, TCP, UDP. This meant that my company could talk to your university could talk to your university. The whole world suddenly was connected. The other thing that happened in 1982 is they ratified SMTP as a way of sending email between these sites. So not only could the companies and networks talk to each other, but the people who worked at those companies and those organizations had a way of communicating instantly for free all over the world with a standard protocol, which opened the door to a whole new kind of collaboration. And so people, academics, researchers, computer scientists, all sorts of people, suddenly they could communicate and share ideas in a way that had never been possible before. About 9 years of this, and this guy came along. Anyone want to tell us who this is? Ah, his name's on the screen there. Isn't that nice? This is Sir Tim BernersLee. Now, I'm going to steal a joke here from Scott Hanselman, which I love. Tim BernersLee's job title is web developer. It could be the web developer, because Tim is the guy who invented the web. Now, he actually invented 3 things. Can anyone tell me what the 3 things were? He published 3 specifications for 3 pieces of technology, or 3 implementations. Anybody? HTTP is one of them. HTML is another one. And the third one is going to be a bit of a surprise. URLs. Yeah. It doesn't seem like anyone had to invent URLs, does it? It seems like they're just obvious. But these were the 3 things in the early 1990s. Tim published 3 specifications. One of them was HTML, one was HTTP, one was URLs. Now, the interesting thing about those, all of them solved a problem independently of the others. HTML provided a standard markup language for decorating and marking up text. HTTP was a transport protocol for getting information from clients to servers. URIs and URLs are a way of uniquely identifying any resource that existed on this massive connected network we all had. Now, there's an interesting footnote here. The computer that Tim BernersLee used to do most of this was this thing. This is now in the Science Museum in London. This is a Next station. You can tell that it is a high availability mission critical server because there is a sticker on it that says, "This machine is a server, do not power it down." This is how we did high availability in the early 1990s before we had load balancing and stuff. Now, the first incarnations of the web, basically the stack that we're talking about is this. They were built on top of static file systems. This is before anyone plugged databases into it. We didn't have CGI, we didn't have PHP or .NET or Node or Ruby or any of this kind of stuff. Your website was a collection of files sat behind a very, very simple server, HTTPD, which went on to become Apache, that would take files and stream them back over the network. HTTP was your transport protocol, and on the other end you had a browser. Now, the first browsers were very, very primitive. The first browser was a thing called Cello that couldn't even display images on the same page as text. You could have a document where the links, and they weren't image tags, they were fig tags for figure, and clicking on one of those links would actually open and render that image, sometimes in a completely different application. Now, it's around this time, 1992, that I actually wrote my first web page. So this is me in 1992. It's also the year I started wearing hats. I was doing work experience at the University of Bristol, and one afternoon they said, "Hey, we got some notes from a meeting here, and we need you to mark them up using this weird thing called VI and put in these angle brackets." And I'd never seen a web page before, so I'm probably one of the few people who wrote my first web page before I ever read one. But you know, kind of the rest is history. And at that point, there kind of been very many servers on the World Wide Web, definitely less than 100, maybe only 10 or 20. And somewhere on one of them, there was the minutes of a departmental meeting, which I lovingly handcrafted into HTML 0.8 or 0.9 or whatever it was. 1993, same month that this movie came out, they published the first HTTP standard, HTML 1.1. At this stage, it was kind of a very, very loose specification. The community was small enough that things were not really ratified. People would exchange ideas backwards and forwards. Lots of stuff worked, but it didn't quite work perfectly, but it worked well enough that it gathered some traction, it started picking up. The next big innovation that came along was this thing. So Mosaic was the first graphical web browser. It was the first browser that came along that could actually display images in the same place as text, or in the same content as text. The thing I never worked out about this is why they decided to make all the page backgrounds gray. because this just kind of became a standard that everyone followed for about the next 5 years. They could have gone black on white. It would have been infinitely more readable. Mosaic lives on for two reasons. Well, there's two reasons right now why it's sort of still interesting and relevant. One of them is that the code base that went into Mosaic went on to become the core of Microsoft Internet Explorer. We're going to talk more about that in a second. The other thing is that the lead engineer on Mosaic went off and started his own company, and he wanted to start a product called, he was going to be his Mosaic killer, or Mozilla. That's where that name came from. And the company they started was this. Netscape. Netscape was phenomenal. It seems kind of hard to believe now because with history and the benefit of hindsight, it seems almost obvious. But Netscape was absolutely astonishing. They completely changed the world. The lead engineer, Mark Andreessen, ended up barefoot on the cover of Time magazine with the Golden Geeks. This is him, one of the biggest magazines in the world. He's on the cover, he's not wearing shoes, he's looking bored. And they're like, who are these kids who are changing the world? Where have they come from? Why have they got all this money? What's going on? There's an entire generation who got taken by surprise almost by this amazing innovation that was starting to happen. Now, there's a couple of really interesting things that I think Netscape got right. One of them is, raise your hand if you have ever paid money for a web browser. Yeah? Netscape cost $50. They had this, very simple business plan. We're going to write good software and we're going to sell it for money, and we'll give you a 30-day free trial, which, as it happens, never actually ran out. So a lot of people are probably still using their 30-day Netscape free trial. But, they had this business model of, we're going to build products and we're actually going to charge people money in order to use them, which kind of seems obvious in hindsight, but a lot of the things that would follow on the internet didn't have anything like that simple a model when it came to how they were going to make money out of what they did. Now, the other interesting thing that Netscape did, when HTTP was first published, there were 4 verbs in it, first incarnation. Who wants to tell me what those were? I'll start you with the easy one, get. Number 2, post. 3, delete. 4, put. 5, head. 4 useful verbs in it. Delete and put were put there because Tim Berners-Lee did not want the web to be a read-only mechanism. He wanted it to be empowering. He wanted everyone who used this to be able to write a website as easily as you could read one. And the early incarnations of Netscape, they all included a thing called Composer, which was a WYSIWYG editor that basically put files on the internet. And it did this, nowadays, if you're maintaining a website, you almost certainly do it through some sort of content management system where you're writing code in a browser and then you're clicking something and it posts a form back to it. There was a distributed authoring model right from day one, from the earliest HTML and HTTP specifications, which said, we want people to be able to delete to get files off their web server, put to get files published on their web server, and then, of course, get and post to interact with those files and resources once they're up there. That kind of died. And I think it's interesting, we had this mechanism built in right from the beginning for publishing things on the web. It fell by the wayside, and now we've gone to all sorts of complicated lengths to work around it and come up with new mechanisms for doing exactly the same thing. But Netscape, they profoundly shaped the web and the way web development would do it, and one of the biggest things that they did was this. Now it's notorious for being awful. Its usability on this is dreadful. It doesn't really add very much value. But the significant thing about Blink is that it was not part of any specification. This was kind of the first example of one of the browser vendors going, where we support the spec, but actually we're going to go and do this other thing, which isn't in the spec. And they did a couple of things. They supported animated GIFs, which was hugely important in the early days of the web, because what every company did, you'd buy a domain name, and then you'd hire somebody to put a little animated GIF of someone digging with the words "under construction" under it, and that would be your entire website for about 2 or 3 years. But, along with things like animated GIF, Netscape added this Blink tag, which I'm actually going to stop now because it's driving everyone a bit unusual. They established a precedent for deviating from the published specifications. I think Blink was the first shot fired in what we were going to come to know as the browser wars. Because suddenly other vendors started going, hang on, if they're not following the rules, we don't have to either. Now, the other thing that Netscape achieved is they scared the hell out of this guy. So this is Bill Gates. This is Windows in the early 1990s. Microsoft basically owned the world at this point. They were unbeatable in terms of personal computing. Apple, we're going to talk quite a lot about Apple later on. Apple weren't really achieving very much. Every year there'd be things going, oh, this is the year of Linux on the desktop, but it never really happened. Windows running on PCs was pretty much unbeatable. And Microsoft made their money and their influence by selling software for money. And when they saw Netscape and they saw Mark Anderson on the cover of Time magazine, they got scared. And they realized they can't compete on features because Netscape was already a much more mature and sophisticated platform than anything they had. They couldn't compete on time to market because Netscape was already there, and they weren't. The only thing they could compete on was price, and the most competitive price to go up against Netscape with was free. And Internet Explorer came out, and it was free. It wasn't only free, it was ubiquitous. You were force-fed it. If you installed an operating system, it had Internet Explorer on it. If you went to a grocery store, there would be free CDs with Internet Explorer on them lying around on the checkouts. They would put Internet Explorer CDs through your mailbox. You know, not even addressed to anyone. They just put free internet CDs through every single home in cities where people lived. You know, it was astonishing. It was so pervasive, the Department of Justice in the States eventually actually tried to take down Microsoft. They said, you need to stop doing this. It's a big antitrust lawsuit proceeding, because they're basically saying, by bundling your browser into this dominant operating system, you're trying to take control of the web. You're giving yourselves a monopoly. It wasn't actually the Department of Justice who broke that, but we'll talk about the reasons for that in a second. It got worse. Internet Explorer 2 was okay, 3 was pretty good. 4 was very interesting in a lot of horrible ways. It was very, very tightly coupled to the underlying operating system. You'd have Windows which would switch from being a file server, a file system explorer, to a browser and back again, and do all sorts of weird stuff with sessions and cookie storage. IE5 was a lot better. IE6, as strange as it seems now, was actually really, really good when it first came out. But the thing that drove people crazy is that all of these things were in the wild at the same time because they didn't have any kind of automatic update mechanism. So if you were a web developer, if you were building websites in the early 90s, you had to support Internet Explorer 2, 3, 4, 5, 6, Netscape version 3, Netscape version 4. You'd stay up all night testing things to make sure that what worked in one browser hadn't broken in another one. You'd go home, the next day you'd get a phone call from your client going, it doesn't work. You'd be like, I tested it in everything, what are you using? They'd be like, I've got Internet Explorer 5.1 on a Mac. And you'd be like, no, don't do that. It's this weird browser that only clients ever used. So you'd then have another day, you'd be like, has anyone got a Mac I can borrow? And you'd spend a day going through and making sure everything worked on that. So it became a kind of very, very difficult and challenging time to build websites because it's kind of pushing the boundary. Every website you ever built, people would be like, what can we do on it that's not been done before? Can we do animation? Can we do rollover GIFs? Can we do rounded corners? Lots of things now that are trivial with CSS and plugins and various things were still actually really difficult, to the extent that if you did them, people would go, wow, that looks amazing. And I presume a lot of clients thought, if people think my website's amazing, they're going to give me all their money. And that's an interesting theme that we're going to cover this morning. Now, whilst all of this innovation, quote unquote, with Internet Explorer is going on, there's another player in the market, and that player is these guys. Well, these are CDs. These were even more ubiquitous than the Internet Explorer CDs. These things were everywhere. We used to use these for target practice in my house. AOL, America Online. Now, you had all of these people, all this fuss about the internet, all this amazing buzz going on. But this is the days before broadband. The whole internet was nothing if you didn't have a way of getting onto it. And what AOL did is they sold internet access. You know, you look closely at the CDs, you can see on there things like 3 months free, 500 hours free. 56K was the fastest modem you could get. And most people in most countries paid a phone bill. So every minute you were connected to the internet, you were actually paying for it. AOL made a huge amount of money. They were massive. They were so big that in the early 2000s, AOL merged with Time Warner. Time Magazine the Time Group owns Time Magazine, owns the New York Times. It's absolutely huge. Warner Brothers is the media and movie studio who own things like the Avengers properties and so on. And these guys give out CDs that let you get on the internet. And in the late 90s, early 2000s, they were as big as the other two. This seems astonishing. They called the thing AOL Time Warner, which I think sounds like something out of science fiction, you know, like the AOL Time Warner has seen your prophecy and it will fail. Now, the big thing that these guys AOL did, they bought Netscape. And then they said, oh, you know, we really need to make one of the classic mistakes that's possible to make in software development. We're going to rewrite this from scratch. We're going to do a full code freeze. We're not going to do anything. That's effectively what killed Netscape. Netscape 4 was out, lots of people using it. Netscape 5, they said, no, we're not actually, we're going to do a full, complete stop development on that, start with a new code base. The code survived because one of the smartest things Netscape did is they decided the code was going to be owned by the Mozilla Foundation, and the Netscape product was going to be owned by Netscape, who were now owned by AOL. And that code lives on in the form of what was originally Phoenix, because it rose from the ashes of Netscape. And as soon as it got out of the ashes, it got sued because someone else was using the Phoenix name. So it went, no, we will be Firebird, and that got out of the ashes, and that got sued as well because someone else was using that name. At one point, you could actually get a plugin where every time you loaded the browser, it would come up with a different random name. Anyone use the KDE, where they have a browser called Iceweasel? Yeah, that's random variation. They eventually settled on Firefox, which is still, ubiquitous. It's now one of the big standard browsers. But that's the story of how, Firefox evolved from the ashes, and Netscape, the company, made one of the biggest mistakes you can make and paid the price for it. Remember this? So this computer is part of an interesting side note in all this. In the late 1970s, two guys called Steve started a computer company you might have heard of, Apple. Apple Computer was hugely successful. There was a lot of hostile politics and management takeovers in the 1980s, and Steve Jobs basically got booted out. What he did, he's gone on record, he said they basically put me in an office that was the equivalent of Siberia and told me not to touch anything. So he quit. And he started two companies. One of them was a computer company called Pixar, who, believe it or not, were originally, the business model for Pixar is we are going to build high-powered image processing computers, and we are going to sell them to research institutes, medical, government, those kinds of things. And a guy called John Lasseter thought, I'm going to make some little cartoons with these computers that I can show off at conferences. Most of the Pixar, the little shorts, they didn't debut at film festivals. They debuted at SIGGRAPH, the big conference on computer imaging and computer graphics. And Disney noticed this, and they went, we kind of like that film you did with the lamp jumping on the beach ball. Do you think you could make a full-length film for us? And they did, and that was Toy Story, which grossed $360 million or something. Steve Jobs started Pixar for $5 million in 1986. 20 years later, he sold it to Disney for $7 billion. That, hell of a return on investment. And the other company he started was these guys, Next. Next sold about 50,000 units. They weren't hugely successful. They were very, very exciting. The computer press at the time was like, wow, look at it. It's not beige. It's black and it looks cool. But they were not enormously successful in terms of cracking the market. There's two great things. One, Tim BernersLee used the Next system to build the first incarnation of the web. John Carmack used the Next station to build Wolfenstein 3D and the first version of Doom. So, these machines, they have their place in history, which is why this one's in a museum now. But fundamentally, Next gave Steve Jobs an opportunity to start innovating and thinking hard about it. And in the early 1990s, as I said before, Microsoft basically were taking over the world. They looked completely unstoppable. Even Microsoft couldn't stop Microsoft. They tried to develop an operating system called OS2 in partnership with IBM, and nobody cared because Windows was so ubiquitous, absolutely everyone was using it. And then somehow Steve Jobs persuaded Apple to buy Next and reinstate him as their CEO. And they came up with this. And the world went, wow, what is that? I want it in my living room. I don't know what it does, but it's cool and it's blue. And there's a couple of really interesting things. This is the first iMac, so this is 1998. And the iMac didn't have a floppy disk drive. Now we've all got, our little relics here. By the way, I think these actually have a disk inside. If anyone's got a floppy drive in their laptop, then try it out. I'm curious to see what happens. And there was this sort of backlash. People went, you can't make a computer without a floppy disk. How are you going to get files off it? And they went, it's got a modem. And people were like, what's that? Why's that important? It's like, no, we don't use disks anymore. We're going to email things backwards and forwards, and we're going to upload things, and we're going to download things from the web, and so on. It established a precedent for innovating by taking things away. So computer came out without a floppy disk drive, massive success. A couple of years later, Apple came out with a music player. Now, there were MP3 players on the market at the time. When Slashdot reviewed the first iPod, they said, no replaceable battery, less storage than a Nomad. We think this is lame. Anyone remember the Nomad? iPod was massively successful, despite the fact it was only FireWire, you had to have a Mac, you couldn't change the battery, you couldn't change the storage. few years after that, Apple come out with a smartphone that doesn't have a keyboard. And everyone's like, you can't have a touchscreen on a phone, it just won't work. Hands up anybody in here who has a phone with actual physical keys on it now. We got one. Is that a Nokia 6310 by any chance? Yeah, those things are unstoppable. After, the apocalypse, alien scientists will come down and be like, there's just these phones everywhere, cockroaches and Nokias, that's all that survived. It's like the phone you dig up in the garden and discover it's actually still got 4 bars of signal after 25 years. But yeah, so Apple established this precedent for innovating by taking away things everyone assumed you were going to need. And this goes on. The iPhone 7 has just come out. They're like, no, we've decided that phones don't need a headphone jack anymore. And the press predictably is going, you can't make a phone without a headphone jack. That's crazy. How are you going to plug headphones into it? Jury's still out on that one. Anyone think it's a good idea? Anyone think that a phone that doesn't have a headphone jack is actually a nice innovation? Anyone think it's really stupid? We'll wait and see. We've all been there before. What's important, though, this thing was hugely successful, and suddenly Microsoft and Internet Explorer's stranglehold on the web showed signs of cracking, because people were buying these things, they were using them, and it was really gaining traction. Now, this made life hell. It was bad enough when we had to support 4 different versions of IE plus Netscape. Now suddenly we had macOS coming along, with Safari was the browser that shipped with that. The number of browsers that you had to support was just astonishing, and all of them were slightly different. They had quirks and they had idiosyncrasies. This book, it's an O'Reilly book. It was about 2 inches thick. Every developer I know had one of these on their desk. It was basically, you could look up anything, any JavaScript function, any CSS rule, any HTML tag, and it would give you a huge table saying, this is what it's supposed to do, this is what it actually does, and this is how it works in 8 different browsers. And so you would be thumbing through this thing going, okay, I need to align this to the center and put it inside a div with a border on it. So you'd look at the CSS rules and you'd be like, okay, so I need this hack and that hack and that hack and that hack. Fortunately, nowadays, this has mostly been relegated to being used as a monitor stand. Because what happened is the boundary, when the web first came along, writing HTML was not programming. A lot of techies got into it, but there was a very clear boundary between writing software and making pages. It was basically, markup and word processing. As expectations around dynamic behavior started to grow and everyone wanted their website to do interactive things and smart things, that boundary started to blur. And what we started seeing is people for the first time applying real kind of software engineering principles to creating websites. And one of the first things they did was they went, this is crazy. We need a level playing field. We need to sort out all of these, idiosyncrasies between these different browsers. We're going to build a framework. And the first frameworks, Scriptaculous, MooTools, jQuery, pretty much all they did was they gave you a level playing field. The early browsers didn't even support things like getElementById. If you wanted to take a button on a page and change the text on it, the way you located that button in your page code, in Netscape was one chunk of code about 25 lines long. In Internet Explorer, it was a completely different chunk of code about 25 lines long. IE had a thing called document.all, which was a big enumeration of all the elements. Netscape had document.layers, which fortunately has died a bit of a death. And so the first frameworks came out to address this problem, to level the playing field and smooth out the problems and the inconsistencies between all these different browser versions. They've got a lot more sophisticated since then. jQuery started out as a way of identifying elements on a page. Now it supports all sorts of rich behavior, Ajax, postbacks, that kind of stuff. MooTools, Scriptaculous, there are dozens of these frameworks. And what this did is it started this mindset about developing code, not necessarily by writing it from scratch, but by finding modules and components that solved a good chunk of the problem you were trying to solve, and gluing them together. And one of the big reasons this is a problem, JavaScript did not have a standard library. JavaScript was originally proposed as a scripting engine that ran inside a browser. There's lots and lots of things that most languages include a standard library to do that JavaScript cannot do, and so, as we started running it in browsers and then on servers with things like Node.js, people started writing modules for all these kinds of things. And one of these was a module that padded strings. On the left, not on the right, on the left, did one thing. And earlier this year, the person who created this, so this is NPM, this is the node package manager, and this is the left pad package from that ecosystem. And the person who wrote this got upset about something, they took it off the internet, and they broke everything. They broke so many things because lots and lots of people, even though they didn't realize it, their project was using a bunch of components which relied on other components, which relied on other components, which relied on this. And the way that that ecosystem had developed, every time you built your system, every time you compiled your code and deployed something to production, it would pull in all of these components and all these dependencies. And taking this one out was like removing that last brick from a Jenga tower. The whole thing collapsed. Eventually, the NPM people, kind of the maintainers of that repository, are like, we actually need to put that back online. Even though the person who wrote it has said they don't want it online anymore, we are going to defy their instructions that we're going to put this back. Because so much stuff depended on this module, this dependency. And it's really important there to think about when you are creating software which relies on components and modules from other people. How are you going to manage those? Why are you using those dependencies? Why is it important? Why do they matter? And what are you going to do if they go away? Those who do not remember the past are condemned to repeat it. One of the reasons why I started putting this talk together, it's 25 years of the World Wide Web. World Wide Web's pretty cool. It's popular. Lots of people use it. But we are, I think, already seeing people who are going straight into web development without any awareness of all the sort of problems and trials and things that we've been through to get it from 1991 and World Wide Web application on Tim BernersLee's Next machine to where we are today. And so I want to summarize and wrap up today by sharing what I think are the sort of 5 key lessons from the history of the World Wide Web. One of the reasons it was so successful is these 3 separate components, HTTP, HTML, URIs. There were online systems, there was CompuServe, there was AOL. These were basically big exes that you just ran on your computer and they talked to each other. By breaking the problem down and delivering this hypermedia system in the form of these 3 simple components, Tim BernersLee and the rest of the team at CERN created a sort of a pattern, a framework infrastructure for developing distributed systems, which is still, going really strong. There's talks on about REST and hypermedia and APIs, and all that is built on the same idea of these 3 components: a way of presenting content, a way of delivering content, and a way of locating content. Simplicity. If you can take a problem, break it down into 2 smaller problems, you'll probably find that each of those solutions actually becomes something you can compose and you can reuse. The lesson from Netscape: never do the big rewrite. If you have code that is running, if you have code people are using, then that is living code even if you don't want to admit it and even if you don't want to work on it. If you decide that old code is bad code and new code is good code, 1, it's not. New code is different to old code. It just has all different bugs that you don't know where they are because you haven't found them yet. And 2, if you do this, you will go dark. And while you go dark, your competitors are going to eat your lunch. If you're smart about it, the way Netscape were, you'll start an open source foundation, and they will pick up your code and they will run with it. And the code itself will survive, but the company will die, the brand will die. It's Netscape's big mistake. The iMac, you can innovate by taking things away. This isn't always a good thing. One of the interesting things that Internet Explorer did is it didn't support put and it didn't support delete. And that's why I think we've ended up with this model where maintaining content on the web is all done by using forms inside browsers where you write your content and you click a button to post a form and things. But it's also, a lot of the time, you can actually really innovate and move things forward. You can progress things by taking something away. Look at your projects, look at the systems you're working on. Are there features there that just exist because everyone thinks they might need them, or because they were essential in the last version? Because there's probably scope to remove things from what you're working on. And if you remove them, you don't have to maintain them anymore. You don't have to build them in the first place. You don't have to maintain them, don't have to upgrade them, don't need to worry if they got any bugs. Best thing you can do to improve code is delete the number of lines of code that are being shipped, because that reduces the number of places that bugs can hide. Remember why you're using packages and dependencies. It's now possible, thanks to the level of sophistication that browsers have, to actually do some really advanced stuff without using any JavaScript frameworks at all. Back in the days of the browser wars, they were pretty much essential. These days, we have a much better specification. The support for it in the browsers that are actually shipping is much stronger. Next time you're trying to solve a problem, trying to build a system, create a web page, before you go reaching for, okay, I'm going to need Angular and Backbone and Knockout and React and all these things, think, hang on, what am I actually trying to do here? Maybe I can do it just by writing some code. If you need to pad a string, think, do I know how to do that? Can I write code to do that? Don't necessarily go and reach for dependencies just because they're there. Think hard about whether that is the best way, both in terms of time to market and in terms of sort of, long-term maintenance and maintainability. Think about why it is that you're reaching for that dependency. And finally, don't get too obsessed with the new shiny. Now, this thing here, file system, HTTPD, HTTP, HTML, it's very, very simple. If you have content that people want, if you've got Wikipedia articles, if you've got a copy of the script for the new Star Wars film 3 months before it comes out, if you have stuff that people are actually interested in and they want to engage with, this stack is everything you need to share that with every connected person on the planet. You don't need JavaScript frameworks. You don't need HTML local storage. You don't need WebGL. What you need is this. And you couldn't get away with saying, I'm a full stack developer, and people saying, okay, what do you know? You're like, I know HTTP, and I know HTML. Full stack developer now means, I'm not quite sure what it means. I think it means someone who does back-end and front-end and probably elastic load balancers and maybe databases and maybe non-databases. And it's a much overused term. People say, oh yeah, we're doing full stack development and this. I used to be a full stack developer who did everything from Photoshop down to actually making network cables with a crimping tool. Yeah? We used to buy disks, and you'd open the server with a screwdriver, you'd put the disk in, then you'd plug it in, and you'd make a cable to plug it into the wall, and then you'd write the code that ran on the operating system you'd installed on it. I think they call that bit DevOps now. But yeah, this stack is good enough to share that content with everyone on the planet, and people who understand this stack, I don't think we can call ourselves full stack developers, but maybe it's okay to start calling ourselves webmasters again. Thank you. Are there any questions?
There is one comment on the screen.
There is a comment on the screen. I forgot to mention the most important improvement Netscape did, JavaScript. Yes, I did. So JavaScript was a language that was invented by Brendan Eich in 10 days under massive pressure. And apparently on like day 7, they went, you need to stop it with all these weird brackets, because he based the language on scheme. He used an obscure research language called Self, which had the idea of prototyped inheritance. He used the idea of functions from Scheme, and he nicked pretty much everything else from Smalltalk. And then the Sun Microsystems marketing people came in, I think, and said, no, your language needs to be Java. And he said, it's not Java, it's a functional language. It's Scheme. He's like, no, just, can you put braces in it or something? And he did, and they called it JavaScript instead of LiveScript, which is what it was going to be called. And we've had 20 years of recruiters going, so you know Java, is that JavaScript or Java? And you're like, they're completely different things. So I hope whoever put that comment, there we go. Apologies for the omission. Yes, Netscape, another massive innovation. Any other questions? Great, thank you very much. Enjoy the rest of the day.